Hello, and welcome to Introduction to Cognition. I am Benjamin Miss, and this is Consciousness. What is consciousness? The earliest discussions of human consciousness come from the philosophers such as Descartes, who sought to solve the mind-body problem. The mind-body problem represents the difficulty of explaining how the mind arises from the brain. Descartes was a dualist, believing that the mind was a separate entity from the brain, guiding our function. Modern evidence from neuroscience suggests that, if anything, it is the other way around, with the brain guiding the mind. Some have even argued that humans are not capable of understanding the very concept of consciousness. Consider the difference between the terms consciousness and metaconsciousness, which means to be conscious of our consciousness. Since consciousness is used to mean approximately the same thing as attention, any living creature is likely conscious. Even a protozoa must have some rudimentary awareness of its surroundings and reproduce. Yet no one would argue that a single-celled creature is aware that it is aware, conscious in the same way humans are. Somewhere along the way, humans developed the ability to consider our own place in the universe. Are we alone? Perhaps some other species on Earth have that ability, though it is unlikely. We are only prepared to discuss metaconsciousness because we have knowledge of attention, perception, language, neuroscience, and the evolutionary history of the mind. We must consider all of these subfields, and we will still likely fall short of a perfect understanding of the evolution of and purpose of our minds. Perhaps it is the mind is one of Gould's spandrels, our modern human metaconsciousness having evolved as a consequence of some other evolutionary pressure. Neural correlates of consciousness. Early investigation into consciousness focused on the differences between being awake and being asleep. Sleep is still a difficult concept to understand, though it is generally accepted that it is a necessary component of life for any living thing that has neurons. Even in the early days of electroencephalogram, EEG, it was clear that something different was happening in a waking brain compared to a sleeping brain. The 4 typical sleep stages were derived by observing the EEG signal change over the course of a typical night's sleep. When a person is awake, they show high beta wave activity, illustrated by low amplitude, fast-paced waves. Amplitude refers to the height of the waves, and the greater the amplitude, the more of your brain is involved in producing those waves. As we progress to the deepest stages of sleep, brain function slows and becomes regular. The first stage is brief and occurs after a person falls asleep and shows high alpha wave activity. Stage 2 seems to be where our brain clears out memories that we made during the day that aren't useful. For instance, you probably remember a lot of what you did today in detail, but not yesterday. Most of the information is simply not relevant, and we clear out space to improve our function. You may have had nights where you didn't sleep, and you might have noticed that the next day you did not function very well. It was hard to pay attention and hard to attend to things. Your brain was probably still maintaining neural connections that were no longer useful, which made it difficult to build new memories. Stages 3 and 4 are also called slow wave sleep and seem to be necessary for deep, restful physical recovery. Rapid eye movement, however, is particularly interesting. It is light sleep, but the primary time when we dream. The less sleep we get, the less time we spend in REM. During sleep, our brains are especially able to clear out toxins that build up throughout the day, those toxins being natural byproducts of neural function. Without adequate sleep, our brains might age faster, and without any sleep at all, we would die within weeks. When we sleep, we are not conscious in the same sense that we are typically conscious. We might intermittently incorporate sensory information into our dreams in nonsensical ways, where a car alarm might become a flock of birds, or a friend's snoring turns into a freight train. Research on dreams tells us that it is normal to have nonsensical dreams, sexual dreams, and to behave in dreams in ways that are not how we would typically behave. One of the major theories on dreams, called activation synthesis, is that during sleep, different areas of our brain might be more or less active depending on what we've been doing during our waking hours. It is likely that sometimes our thalamus wakes up and attempts to tie these semi-random bits of activity together, and this attempt to make sense of brain events that are not related can lead to our dreams. This activity can also help us to understand waking consciousness. Our brain is regularly tying various areas of activity together into a coherent whole. The reason we may behave strangely in our dreams is that we are not entirely ourselves. The brain areas responsible for our personality are not all active at the same time. So a fearful person might find themselves joyfully swimming with sharks, or a person who is not typically anxious might find themselves unprepared for an exam in a class they aren't even taking. When we dream, we are simply conscious, aware, able to attend, but lacking in metaconsciousness. That is why when we remember our dreams, it often seems as if the experience happened to someone else. Some people can take control of their dreams rather than just passively observe. This is called lucid dreaming. If we are lucid dreaming, we are metaconscious, aware of our conscious state. Consider the perceptual awareness that's required for brain function. Problems with brain function will lead to diminishing consciousness or a lack of consciousness. Major frontal lobe injury, like the railroad construction accident suffered by Phineas Gage, might lead to a change of personality so great that we are no longer the same person. Slow neural degeneration, such as that seen through the progression of Alzheimer's, would also cause a change in that person. Someone in a coma could still maintain some conscious awareness, but this would depend on the neurological cause of the coma. A patient with severe brain damage might be in a persistent vegetative state, where the patient would have sleep and wake cycles and can demonstrate reflexes such as jerking their hand away when poked with a pin. We would not consider someone in such a state conscious. The patient, though responding to some stimuli, lacks awareness. Brain death is when there are no longer sleep-wake cycles or brain function. These patients might be kept alive through the use of a respirator and forced feeding. But without the brain, there is no consciousness. The link between the brain, perception, mind, and function suggests that consciousness requires brain function. Neuroscience should eventually be able to link brain function to our perceptual and even to our introspective experiences. In addition to the thalamus, a brainstem structure called the reticular activating system, RAS, appears necessary for maintaining consciousness. This structure extends into the midbrain and projects axons through the cortex. Damage to the RAS has been shown to cause a major change in consciousness, with consequences ranging from coma to death. Interestingly, damage to any of these structures is usually required to be bilateral in order to have the maximal effect. This means if you only damage the thalamus in one hemisphere of your brain, you might have deficits, but not nearly as severe as if both sides were damaged. Most of our brain structures come in pairs. The issue of consciousness in the brain is further complicated by the study of patients who have had their corpus callosum cut in a last-ditch effort to control a major seizure disorder. These patients have independently functioning hemispheres of the brain, with the left side and right side no longer in sync, able to perform separate tasks. Each hand can move independently when asked to solve a problem, each hemisphere working alone. When tested separately, each hemisphere appears to have its own personality, with separate goals and desires. Definitions and debates. If you could build a powerful enough computer, would it achieve human-like consciousness? Could we become like the gods? creating a self-aware intelligence in our own image? Not yet. We do not yet understand human consciousness enough in order to do that. We have philosophers who describe life and the universe as absurd and meaningless, only because we have the ability to turn our consciousness inward and examine our own existence. The study of consciousness is so difficult, so fraught with debate and uncertainty, that it is viewed often as a career killer in many fields. Those who do study consciousness tend to be older, established researchers who are willing to take risks. For instance, Francis Crick, one of the Nobel Prize-winning discoverers of the double helix structure of DNA, spent much of the latter part of his career investigating the neural correlates of consciousness. He experienced far less success with this endeavor. His work with Christoph Koch yielded data on where the brain was active during conscious experience. This work, however, might help solve Chalmers' easy problem of consciousness, but does not help us understand the mystery of consciousness itself. An illustrative example of what it means to be conscious comes from John Searle and what he calls the Chinese room problem. This is related to the idea of the philosopher zombie, and is Searle's attempt to demonstrate that consciousness exists. In this scenario, a person feeds paper with Chinese writing into the room, where a non-Chinese speaker has to translate the Chinese into English. The person completes the translation by using dictionaries and books without knowing what any of it means, and hands back an English translation. This example is meant to show that we could easily function in this world, completing all of our tasks, such as working, communicating, and interacting with others, without any actual understanding of what we're doing. To Searle, consciousness is indeed special, our sense of who we are that goes beyond the mechanics of daily living. Human consciousness must be more than simply being aware and attending to things, but we know that much of our attention is directed to things without our intent. The world around us commands our attention, especially in regards to survival and reproduction, the main drives of natural selection. Yet, for humans, these are not simple tasks. We cannot simply avoid death and eat until we grow large enough to divide in two, as many protozoa do. The modern human living in a city is far removed from having to find food and shelter in nature. Being removed from the daily struggle to simply survive in some way removes us from understanding the minds of our ancestors. Yet we can still see the philosophical and religious remnants of the basic ways that they saw the world. For instance, the belief in the existence of the human soul and a life after death is strong in cultures across the globe. When we study similarities in human beliefs across various cultures, it allows us to consider how the mind produces those beliefs. This is another window into cognition, where the study of consciousness may not help us understand the nature of the world, but can help us understand the nature of the mind. The Oxford physicist David Deutsch has argued that expecting to create an AGI, artificial general intelligence, without first understanding how it works, is like expecting skyscrapers to fly if we build them tall enough. This means that he thinks we are going in the wrong direction. We do not understand consciousness enough in order to design an artificial intelligence capable of it. Metaconsciousness is not an emergent property of any powerful computation machine, but requires our neural anatomy and our specific social evolutionary history. Computers do extremely well at specific tasks, like outperforming us at Jeopardy and chess, but computers are nowhere near being self-aware. Something big is missing. Many have attempted to explain the hard problem of consciousness and the mechanisms that lead to our subjective experiences. In our attempt to define these specific difficult terms, consciousness means awake and aware. This definition might describe James's transitive thought and Kahneman's System 1. Metaconsciousness is the ability to contemplate our own awareness of our internal processes, more like James' substantive thought and Kahneman's System 2. When we feel a certain way, we think about why we feel that way, and we attempt to give meaning to those experiences. Theories of consciousness. Those well-versed in the study of metaconsciousness will disagree with most of what I write here in regarding theories of consciousness. This topic is dense, contentious, and at times it seems unlikely that consensus will ever be reached. In the introduction, we reviewed ways of understanding consciousness, monism and dualism. The two main types of monism to consider are physicalism and idealism. Physicalism is the belief that only the physical world exists, and idealism is the belief that only consciousness exists. Since dualism requires two explanations for consciousness, we can focus on monism. Is the mind simply an illusion? If you're okay with that, you can stop with physicalism. There is research that shows that the mind follows the brain. We can measure neurological changes related to mental states and show that those mental states can be predicted by studying the responses in the brain. Therefore, the mind is most likely an illusion produced by the brain, a program that is running on the hardware of the brain. The main problem with physicalism is that it cannot explain the reason this program exists. Certainly, it would be better for our mental health if we avoided reflection and never questioned our motives. Yet, we are more likely to make better decisions if we consider other people in our lives and analyze different possible outcomes. It can be painful to consider outcomes and ruminate about things we lost. So it seems that our metaconsciousness, though especially when coupled with our emotional experiences, can be maladaptive. Overall, there must be benefits, but there are also costs like obsession and fear of possibilities that may never occur. Metaconsciousness is not perfect. As with all products of evolution, the benefits outweigh the costs. Traditionally, attempts to solve the easy problem of consciousness, the neurological processes involved in our awareness, have focused on the brain. It is possible that by focusing instead on the mind and the cognitive structures involved in our experience of metaconsciousness, we might begin to understand the hard problem of consciousness. Why does metaconsciousness exist at all? There are really only two possibilities. One is that it represents an adaptation on its own, and the other is that metaconsciousness is a product of other cognitive adaptations. While physicalists like Dennett tend to ignore consciousness as an illusion, substance dualists and neutral monists see it as a real thing, but not separate. The experience is real to us. If we accept the experience of metaconsciousness as being what matters to us humans, we can then analyze the cognitive processes involved in this experience and understand why it exists, solving the hard problem of consciousness. We first must accept that human metaconsciousness is unique and remind ourselves that we are not talking about simply being aware of the world around us, but being aware of our own awareness and our ability to turn our incredible ability for analysis inward. This introspection makes us unique, as we see little evidence of this kind of thinking from other species. Now that we accept that metaconsciousness is unique to the human mind, we look at what cognitive structures allow for this. There are two key components that contribute to human metaconsciousness: theory of mind and recursion in language. By this understanding, I would argue that humans did not develop metaconsciousness until after age 4. Theory of mind. As discussed in the chapter on development, theory of mind is the ability to take the perspective of another person. We need this ability in order to work together. I can trust you because I can predict your behavior. I assume your mind works like mine. You can see the inherent problem here. People who are selfish expect other people to be that way too, and will also violate our expectations regarding cooperation. Yet we are still able to predict the behavior of other people well enough that we have indeed built cathedrals and skyscrapers and rockets. Working with others causes anxiety. If you do not work with me, I am at risk. In a Stone Age environment where we are fighting daily for survival, if you fail to cooperate, it could be catastrophic for me or for the tribe. I have to have a mechanism that allows me to predict your behavior and plan accordingly. Social animals appear to have rudimentary theory of mind. Animals that hunt together must be able to predict what their companions will do. This is not like swarming, an emergent behavior. This is an ability highly selected for that allows for the success of a species of social hunters. Humans have large social groups, which correlates with intelligence, not just with primates, but with many other species too. Some solitary creatures, like octopuses, show apparently high intelligence, but those species that collaborate creatively tend to show the best ability to problem solve. This means that it is likely that your dog has some kind of theory of mind, but that your cat does not. Dogs are pack animals that collaborate, while cats tend to be solitary hunters. Yet we can only guess about their internal experiences. They lack the language to tell us how they feel, and it is unlikely your animals experience existential crises outside of the immediate question, how can I get this stick that's long through this narrow doorway? We apply our theory of mind not just to other humans, but to our pets, machines, and inanimate objects. Perhaps you've seen one of the ubiquitous digital assistants, like Siri or Alexa, get jealous. There are videos of people calling their digital assistant the wrong name, and the response from Siri might be something like, "Who is Alexa? Why don't you ask her?" Obviously, this is an automatic response designed by a programmer with a good sense of humor. But we are already applying our theory of mind to this digital assistant, and we cannot help feel, if only for a moment, that we have offended her. We know your phone cannot feel offended, but we can, and if it appears to be offended, then we feel bad. Theory of mind is an automatic function that is applied anytime we think we may have come into contact with another mind, and there is always uncertainty, including the example of the philosopher zombie, where we can never know for sure whether other people have subjective experiences, like we do. We can be forgiven for anthropomorphizing electronics and animals, since we are, in a sense, anthropomorphizing each other. Even with animals that do show some ability to work together and predict behavior, they do not demonstrate metaconsciousness. We cannot ask either of them about their internal experiences, or what it is like to be a dog or a crow or a dolphin. To attempt to explain our qualia requires language, the other component of metaconsciousness. Recursion in human language. Some believe that recursion is really the only human ability that separates us from other species. Recursion allows a concept to be copied and placed inside itself. If you find this unclear, you are not alone. This incredibly powerful ability is also notoriously difficult to define and can be understood better with examples. It is part of the computational aspect of language. For example, there is no longest sentence in any language, because we can always add more. We are limited only by our ability to remember information, not by the way language works. Consider this sentence. This is the longest sentence ever written. That would be a ridiculous statement. James Joyce managed to get through thousands of words strung together without the help of a period. However, we can make our sentence longer if we say, Ben wrote, this is the longest sentence ever written. You just added 2 more words by embedding my sentence in another sentence. You take James Joyce's 1,000 words and add, James Joyce wrote, embedding his sentence after your words. Recursion in language allows for a phrase to be embedded in another phrase. We allow verbs to have whole sentences as their objects, like the verb wrote, for example. You could say, I said that Ben joked that Joyce wrote, and continue indefinitely. However, after a little while, we would have trouble understanding the sentence. Our memory is limited. Language is not. Other examples come from programming. You can write functions that call themselves repeatedly until some other condition has been met. Perhaps you wanted to print a number on the screen every second until you reach the number 20. You could write a program that write 1, waits a second, write 2, and on and on. Or you could write a program that writes a 1, checks the number on the screen, and if the number is less than 20, adds 1 to that number each time. It might seem easy the first way, but with the second way you can have it count to 1,000,000. You wouldn't want to do that the first way. Recursion allows an infinite regress in the same way René Descartes' Cartesian theater cannot explain consciousness, but does a good job of demonstrating recursion. Descartes argued that inside the mind is a homunculus, or little person, steering consciousness. Remember how the words consciousness and soul have often been used interchangeably? Descartes' little person would steer your attention, guiding you to whatever is necessary for you to attend to. When Daniel Dennett asks, who is steering the homunculus? The whole concept collapses. A little person would have to steer the little person in your mind, and a little person would have to steer the little person who is steering the little person in your mind, and I've already lost track of who is steering who. Descartes could be right if we accept this infinity of homunculi. An easier explanation is that those things most relevant to our survival and reproduction grab our consciousness. Descartes' dualism may rest on believing that the soul is guiding the body, yet it does not explain what is guiding the soul. Human language, resting on this recursive ability, opens other avenues for understanding the world. In English, the modal auxiliary verbs such as could and might open up possible worlds and allow us to consider many scenarios. Combine this idea with theory of mind, and now we are able to consider hypothetical situations with other humans. We can imagine many possible outcomes and consider how we would behave and work with you. The anxiety inherent in survival now exists outside the immediate as we consider possible futures. This existential angst, anxiety about the future, is unique to humans. It requires the ability to think about your actions and the actions of others. Human metaconsciousness. To think about these two components together, theory of mind to work with others by predicting behavior, and recursion allows us to project infinite possibilities and consider complex concepts. We apply theory of mind to our own behaviors, and recursion allows for the complex language necessary to describe them. Our mind tells a story about our brain, so that even though the mind is produced by the brain, our mind attempts to explain what our brain is doing by observing our brain function and our behaviors. Experiments have shown that the mind can follow brain activity, and it is not immediate, but rather delayed by however long it takes to create a mental model to understand the stimuli. Our recursive ability that drives human language and the exploration of possible worlds allows us to explain our own behaviors. We know the major driving forces behind what we do involve the basic drives of survival and reproduction. In a complex, modern society, we can lose sight of that. For instance, I'm not worried about starving or freezing to death if my hut burns down. I want to have good relationships with my friends, I want to do well at my job, and I want to enjoy my hobbies. Yet those social relationships and work successes are necessary for my survival and reproduction. My hobbies, assuming I have time for them, keep me from spending too much time considering possible worlds and experiencing the anxiety those possibilities create. There is one more piece of the consciousness puzzle to consider. Oakley and Halligan, 2017, conclude that there is no effect of our personal awareness on the function of the mind or brain. In their estimation, metaconsciousness is a complete illusion that allows us to communicate our personal experiences and beliefs to others. There is no system 2, no substantive thought. This model does away with free will and personal drive. They liken consciousness to a rainbow, produced by environmental factors but having no effect on the environment. To many researchers like these, we are simply a product of our neural function, and if we could map our neurons completely and observe the entire environment, we would be able to perfectly predict our behavior. The objection to this idea is the very fact of quiet, contemplative meditation. We are not reactionary automatons simply responding to inputs, but instead we can show that our minds are able to affect the brain, quiet the obsessive thinking, and allow us to ignore our own programming. The development of theory of mind allows us to work together, but it also allows us to question our own minds. When we consider our own beliefs and experiences, we are capable of change. The psychological concept of insight, that self-awareness of our errors in thinking that allows us to change, can allow us to change. If we had no ability to affect our own existence, then the act of quieting the mind through meditation that some people choose to engage in would also be part of that illusion. In the end, our belief in our own metaconsciousness is like our belief in free will, untestable and a matter of faith. It is doubtful that we will ever be able to discern whether consciousness is an illusion driven by a physical brain or whether consciousness is the only true state of the universe. Yet when we consider that our human consciousness is a real and meaningful experience, we can see that it is a product of our incredible human minds. Metaconsciousness is real and meaningful, inexorably linked to our brains, yet able to turn itself back on our brains to improve our lives and experiences. I hope you've enjoyed our discussion of consciousness today. Thank you, and I look forward to more discussions in the future.